Welcome to The Explainer. Today, we're diving into a brand new paper fresh from the world of AI research called CoT, Chain of Thought in J-Space. If you're at all fascinated by how machines reason and solve complex problems, you're going to love this because it introduces a fundamental breakthrough. Let me ask you something. Does AI really need to think in English, or French, or Mandarin for that matter? We spend so much time building these massive language models, essentially forcing them to use our human grammar to process their internal thoughts. But is that actually the best way for a machine to think? So here's our roadmap for today. 1. The AI reasoning bottleneck. 2. The flaw in hidden states. 3. Welcome to J-Space. 4. How J-thoughts actually work. And 5. Unlocking next-gen AI performance. Let's get right into it.
All right, section 1, the AI reasoning bottleneck, or why words actually hold models back.
You've probably heard of standard chain of thought, right? CoT. It's a prompting method that basically asks an AI to just think step by step. It's exactly like when you or I speak our inner monologue out loud to solve a tricky math problem. Carrying the 2, dividing by 4. By carrying these intermediate states across successive computation steps, the AI gets way, way better at reasoning.
But here's the catch. Relying on natural language is actually overly restrictive. Here is the bottleneck. When an AI uses standard chain of thought, it's forced to fully verbalize every single transient computation in complete, fluent sentences. Imagine if every time you recognize a friend's face, you had to mentally write a full descriptive paragraph before you could even remember their name. It literally just slows the whole system down.
Which brings us to section 2, the flaw in hidden states. Basically, the messy alternative. So to bypass this whole language bottleneck, engineers tried something called latent reasoning. The idea here is to remove language constraints entirely by recurrently propagating continuous hidden states. Basically, instead of forcing the AI to spit out perfect English, latent reasoning just passes along a dense chunk of math, a hidden vector. It's kind of like the AI is just passing abstract vibes to the next computational step instead of actual words.
But as you can probably guess, this creates a classic Goldilocks problem. On one hand, language-based chain of thought is super organized, but it's way too rigid and slow because it demands fully verbalized sentences. On the other hand, latent reasoning is fast, sure, and it avoids the language trap, but it lacks any explicit organization. It just passes dense hidden vectors as a whole. So the AI ends up drowning in this messy wave of numbers, really struggling to select exactly what it needs for the next step. So what's the solution? Section 3. Welcome to J-Space, the perfect middle ground. This paper defines J-Space as a vocabulary-indexed coordinate system within the model's hidden representations. Now, what does that actually mean for us? Think of it like a highly organized system of shorthand notes. It keeps the AI linguistically grounded, but it absolutely doesn't force it to write out a fully decoded sentence. Honestly, it's exactly like a line chef using quick, standardized abbreviations on an order ticket instead of writing a whole poetic essay about the dish. All right, let's look at the mechanics. Section 4, how J-thoughts actually work, the 3-step cycle. The researchers built a recurrent reasoning framework based on a really brilliant 3-step cycle. Step 1, within each cycle, the model computes in its full massive hidden space, just crunching all the numbers it needs. Then, step 2, and this is the magic boundary line, instead of passing that whole messy vector forward, it expresses its intermediate state as vocabulary-indexed coefficients. This neat, curated little package of info, that's what they call a J-thought. Finally, step 3, it carries those specific coefficients forward and maps them right back into the model's hidden representation to kick off the next cycle. And this design is a huge breakthrough. CoT requires neither a fluent intermediate rationale, so it totally avoids that slow language bottleneck, nor does it need recurrence over the complete hidden state, so it skips the messy chaos of latent reasoning. It beautifully extracts only the useful information into that shorthand J-thought. Which leads us to the payoff. Section 5, unlocking next-gen AI performance, crushing the benchmarks. When they actually tested this out under matched inference settings, the base model, called CoT0, went toe-to-toe with the absolute strongest latent reasoning baselines available. And the results? It matches or exceeds them on literally every single benchmark they evaluated. Turns out, organized shorthand is proving vastly superior to passing around messy hidden vectors. But wait, it gets even better when the model is actually trained on this method. CoT Train achieves the highest scores across the most rigorous testing categories out there.
mathematical tasks, scientific tasks, complex coding problems, and structured path reasoning. Basically, by giving the AI an efficient way to just hold on to its thoughts between steps, it absolutely dominates the hardest logic puzzles we can throw at it.
So, what's the grand takeaway here? CoT essentially creates a brand new, hyper-efficient language of thoughts specifically for machines. Think about it. For years, we forced AI to speak exactly like us, which slowed it way down. Or we let it think in pure math, which made it completely disorganized. JSpace is that perfect bridge. It's a linguistic coordinate system unlocking unprecedented reasoning speeds, all without losing that crucial structure.
Which leaves us with one pretty wild question to think about. If AI no longer needs our human language to structure its reasoning, what on earth will it learn to solve next? Thanks so much for joining me for this explainer. Keep asking questions, and I'll see you next time.